This lecture I want to talk about how we're going to design the frame, and there's a definite process to this. First thing you're going to want to do is research existing designs. Don't need to recreate the wheel. There's lots of people that have built vehicles similar to this, so go online, search for mini bike frames, small motorcycle frames, those kinds of things. Pay attention to some of the details. For example, how does it look? We want it to look nice, look professional. Is it the proper size? It doesn't make a lot of sense to use some big 1000cc motorcycle as the concept for your frame. Think of something small. Also, don't make it too complex because we want to be able to manufacture this. Of course, keep in mind the performance criteria such as the size of engine. So the space right here is important to us, but you don't want to have so much room that it looks like you have the motor's too small to propel the vehicle, and likewise you don't want the motor sticking out so you can't install it. Pay attention to tire size. Now we can always widen these frame rails and widen the forks. It's pretty easy to do, but pay attention to the scale of the frame as you do that. And also really important is pay attention to the rear suspension system. A lot of these mini bikes like this has a solid rear axle, so you just bolt the axle and it has no suspension. So what we're looking for is something that has a swing arm rear suspension. So that's going to change the way the frame is designed. So here's some examples of some different frames that I found. Just kind of quickly did a Google search for mini bike frames, and some of these are applicable and some are not. These, again, pay attention. These all have solid rear axle mounts, so they don't have suspension systems. So you're going to have to incorporate that into this design. Now these frames here could have a suspension system added to them. They would need to be lengthened. This one definitely has the swing arm rear suspension. You can see even some of the mounting material that goes with it. So that's not a bad concept there for something. We may have to scale it for the size of tires and so forth, but that's not a bad design. But anyway, you can get an idea of how the frame pieces fit together, and there aren't that many components to make this work. Again, we're not trying to get something that's too complex. Once you have found something you feel like is a good reference, and you want to create a basic layout that's going to have the dimensions that you need. Now this is a very different design, so don't use these numbers. They don't really mean anything other than it's a good example. So come up with some basic ideas of how big the frame is going to be, what the bars are going to look like. So I did an orthographic sketch on, I just used AutoCAD, but you could do it with a pencil and paper. The beauty of doing it on CAD is you can actually find out what the dimensions are and the proportions. So I just came up with some numbers. I looked at how much space I need for the motor. Now this particular design has a very small motor in it, and it isn't really set up for a rear suspension. So again, be careful about copying this. I don't want your design to look like this one. So on the top, I'm gonna have two backbones. So that top bar is called the backbone. This will be where the seat is. The motor will sit in this area here. Your front fork is going to be attached here to the neck. Rear suspension, rear tire will be back here. This is what the front view of the frame looks like. These bars here are actually angled out. So that'll give you a good starting point. Don't just try to start modeling the frame until you have a concept for how it's going to go. Now, this is definitely not going to be what my final product looks like, but it's a really good starting point. The other thing to pay attention to is we're going to bend the tubing. We're not just going to butt pieces of tubing together. It looks very, very poor when you just butt pieces of tubing together and weld them. So try to have bends wherever possible. So you're going to have to leave some space in the length of this to allow the bends, because they'll take up a fair amount of length on the tubing. Likewise here, when you have bends, that's 9 inches long, but those are 3-inch radius bends. So that's 3 inches, and 3 inches is 6 inches of this width here. Once you have a concept for what you think your frame is going to look like, and you've sketched something out in terms of dimensions, you want to think about how we're going to break this frame into manufacturable pieces. So we're not just going to build the whole frame out of one piece of metal. We're going to cut it into separate pieces. So we'll cut and bend and notch all the tubing to fit together. So here's an example of a bunch of pieces that would go together to make a frame. So we're going to have to bend all of these. So we need a detailed drawing for each of those, which means we're going to need a model for each of those. So what you'll do is model each of these separate parts and then we'll assemble them into the frame, and that'll give us an assembly drawing. Then that all these will be ballooned, and you'll have a parts list to show how the pieces fit together. So we're going to make individual pieces, and then we'll attach them together to create the assembled frame. Once you've thought about how you're going to break the frame down into manageable pieces, and what I would tell you to do is don't do more than 2 bends per piece, otherwise it just gets really difficult to manufacture. So a lot of times you're going to have straight pieces, but most of them will have some sort of a notch. Again, you're not just going to take a piece of round tubing and butt it up against another piece of round tubing. You're going to notch these out so that the tubes fit together nicely. See how these are all notched. Now when one tube butts up against another flat tube, then that's perfectly okay, because then we'll actually put another tube inside there and weld around there, so it'll make a very, very strong joint. So I've got, those are the pieces I need to make up my frame. For creating the assembly, it's a good idea to make sub-assemblies if you have kind of complicated pieces that fit together. So this is the backbone of my bike. The steering neck is going to mount here. That's why these are notched. This is where the seat's going to be. So this is, again, we can't make this out of just one piece of material. This is actually going to be 4 pieces. That'll be 1 piece. This will go up to here. That's 1 piece. That's the 3rd piece, and then that's the 4th. And these 2 are different because they're opposite images for that steering neck to fit in there. So the reason this is 2 pieces is just be too difficult for us to bend. If you had a very expensive computer controlled bending machine, you could make a part like that, but that's very difficult to make and have it turn out accurately. So that'll be made up of 4 pieces. So once I've modeled each piece, I'll create a sub-assembly of that backbone, and then from there I'll build on the rest of my parts to make the frame assembly. So this is what my sub-assembly of my frame. It's a sub-assembly because it doesn't have everything on it yet. It doesn't have the motor mount, doesn't have the rear suspension mount, doesn't have seat brackets, doesn't have a lot of things that you need to call it a finished frame, but it's a really good starting point. So you can see how my backbone sub-assembly is there. So I inserted that into this assembly model, and then I started adding these pieces. Now this part here, this is 1 piece up to here, and then this is a 2nd piece, and the left and right sides are the same. Left and rights are the same. So I just had to model one of those, insert it twice into the assembly, model one of these, insert it twice into the assembly. And notice how all the tubes are notched so that they fit together. Makes a nice tight assembly, and then you'll weld that all together into your frame.